Yeah, so I'd like to just chat tonight a bit about microservices, maybe just give you a brief introduction. Most of you have probably heard of microservices, and they certainly are starting to make a big impact in the market right now. Who am I? My name's Robin. I've been a developer for close to 30 years. I've been involved in internet development since about 1995, and I currently work as part of the Dev2 team, which I'm pretty excited about. We're doing some very interesting work right now around microservices. So I'm going to kick off with just some information about what's happening in the world right now. So this is basically a service-orientated architecture strategy zeitgeist. So 300 of the top companies in the United States were surveyed quite recently about their strategies and service-orientated architecture. And I'm just going to give you some statistics about from the feedback that they got from the survey. So, for instance, 86% of the respondents said they were under a moderate or extreme pressure to deliver IT services faster than last year. And if you read into this a little bit, it essentially means that IT companies, IT teams, are under a lot of pressure to change, and they're battling to change because they can't adapt fast enough. So hence the pressure. So 75% of organizations have an application programming interface and API strategy, and more than 50% of them say they are generating revenue from their APIs. 25% cited software as a service as their top integration priority, and 14% cited API development or self-service IT as their top integration priority. So companies are starting to see the value of clients being able to service themselves in terms of their data, and obviously it's a good way forward. But this does create a lot of extra complexities within corporate systems. Okay, so among the 300 companies that were surveyed, there's a group among them who are essentially the $10 million plus club. So they consist mainly of financial service companies and media and telecoms companies. So 33% of the financial service companies were deriving more than $10 million per month from their APIs. And 50% of media and telecoms organizations are deriving that amount of revenue from the APIs. So there's big money in making data available. And obviously there's a huge cost-saving implication too for that. It means you don't have to have staff providing that information. So it's really a win-win for business-to-business integration. Of that $10 million plus company, 58% of them are currently integrating 100 more of their internal apps using service-oriented architecture. And other companies outside of that group of companies, they're looking at it, 70% of them are looking at integrating at least 20% of their applications via SOA. Then something that's also came out during the survey is fog computing. And for those of you who don't know, fog computing equals the Internet of Things plus the cloud. Internet of Things is really starting to take off in a big way. When Microsoft Windows 10 has got an Internet of Things version, which you can run on small devices like the Arduino or NetDuinos. So there's a huge move towards it. But more traditionally, I think a lot of these statistics come from cell phones or devices connected to the internet. So a cell phone is typically an Internet of Things device. So 77% of companies already have an Internet of Things strategy. 75% rank that strategy is very important or important to their business plans over the next 12 months, which is a great number for guys who are doing mobile development. It's a very good number. 45% said their main driver of IoT was to improve customer experience and engagement. And again, that talks directly to probably mainly mobile phone and tablets sort of interaction with their clients. And 70% of the respondents say that their organizations are either currently integrating wearables or plan to do so in the next 12 months. Now, I think that's quite an interesting number. I mean, there are not that many wearable devices that you can think of right now, but out of those 300 companies, 70% are looking at it. I mean, for the common wearables right now, of course, are Google Glass, and there are a few others, but and probably like watches, for instance, Apple Watch. But in terms of wearable devices, there's definitely a very huge interest in integrating those devices. So fog computing is quite interesting in itself because the cloud definitely cannot handle the amount of data that the Internet of Things can. So in terms of how the strategies are going to evolve, and this information mainly comes from Cisco, is that the Internet of Things is definitely going to start to feed information through to the cloud platforms, whether they be internal inside companies or public clouds like like Azure, for instance, or Amazon Web Services. And most importantly, in terms of this presentation, 66% say that microservices will be important and very important to their business strategy in the next 12 months. So 300 of the top companies in the world say 66%. 66% of them say microservices are very important or very important. So there's a very, very strong trend towards microservices, and so that's kind of I'm going to feed into that a little bit in this presentation. I'm going to start off by just touching briefly on what microservices are and how they compare to current systems. So traditionally, when we have systems in companies, we have what we call a monolithic architecture, which means you build an application. So even if, for instance, if you're building a website or something, you generally have one website, and you start to integrate all your services into it, your URLs and everything, whatever services you provide via it, generally go into one code base. So that's called a monolithic architecture. Whereas opposed to a microservice architecture, which is a slightly different approach to things, and I'll show you in a few minutes how the microservice architecture actually works. So in this picture, on the left side, you can see what is typically a monolithic application. So a monolithic application puts all of its functionality into a single application, which is how we currently mainly design system these days. And so it's essentially one thing. So if you make a change inside a monolithic application, you have to deploy the whole application. And if something breaks in the deployment, you have to roll back the whole application. So it does have some pros and cons. So for instance, it's very quick if you want to do a startup app or something and build it and get it out into the market, it's a lot easier to build a monolith than to build a microservice-based application. But they tend to scale and they get unwieldy, and after time, they need to be revisited and often rebuilt from scratch, and that happens a lot in business. On the microservice side, a microservice architecture puts each element of functionality into a separate service. And essentially how microservices work is they're networked together. So a very good comparison to what a microservice is would be like a method in code. So you would have a whole lot of methods, and you would use the methods, how you would have methods using other methods through, like in microservice terms, we'd call it orchestration, but that would, in normal code, you'd just be writing code and consuming methods inside libraries. And importantly, microservices communicate each other via a standard network protocol. So how do you scale monoliths? Well, you make multiple copies of them, or you get very, very big machines to run them on. That's really the only way you can scale monoliths. There are other ways to do it, like have different bigger databases, but essentially it's moving big things around, and fixing those big things brings on the challenges that I spoke about earlier. Whereas with microservices, if you need to scale microservices, you can actually just fire up single microservices. So for instance, if you had like this microservice over here became very, very popular and very busy, your system managing your load would just spawn a few more microservices to manage it and direct the traffic. You'd get automatic load balancing across your microservice containers. So microservices scale by distributing instances of the microservices across servers and replicating as needed, which is a totally different take on things. But it has a lot of advantages, but it also has some disadvantages, which we'll talk about I'll talk about just now. So some common characteristics of good microservice design. A good way to see microservices is to see them as components. So build it, a really good way to do it is to build single function microservices. So if your microservice just does something, just fetches some data, just returns something, you can keep them very simple. And because they're simple, they become reusable. So it's a very good model for reusability. And reusability has kind of dropped out of our, although we've tried to do it over the last 15 years, it's become very difficult to actually do real reusable code. And we write code and we think it's reusable, but code these days hardly ever gets reused in the real world. Whereas microservices bring back the possibility for proper reusability within inside building large-scale applications, and we've experienced that quite a lot. That it does really work to build systems, and it's really easy to get the modules of your applications into parts that are into components that are different, and you can reuse them without actually duplicating any kind of functionality. And one way to do this, one way to do the approach of using microservices is to use an agile methodology called domain-driven design. So what you do is essentially you divide your organization up into domains. So for instance, if you were building a store, for instance, you would have inside your store on the internet, you would have part of the domain would be the warehouse. One part would be ordering, part would be dispatching it, part would be handling the payments. So you'd have different domains within that actual application, and within those domains, your services would be very focused towards those domains. So if you want to know about financial transactions, you go to the financial service domain within your microservice architecture, and that's where it resides. And one of the nice things about this is if something goes down in one of the sectors, the rest of your system just carries on working, because microservices are totally decoupled. So if your payment system goes down for a while, it doesn't really matter. You can still keep taking orders, and you can queue them up until that service comes back online, and it can continue to process them, for instance. So there are a lot of advantages to microservices in terms of being able to build very, very large-scale applications and deploying them and running them in the real world. One way to look at microservices is to look at them as product-focused. A microservice delivers something. You build it to deliver something, normally XML or JSON or some kind of data, to return to be consumed by something else. So you'd have these product-focused microservices running within domains, which is the sort of ideal way to build microservices. And an important part about microservice architecture is that they should have smart endpoints and dumb pipes. So a good example of that is TCP/IP. The pipes in TCP/IP are dumb, but your endpoints, like your websites or HTTP connectors or FTP sites, those endpoints actually have the smarts within them. So you remove the complexity from within the actual pipes, which something that has started to happen in systems like enterprise service buses, and you move them into the endpoints. And this way it's easy to manage where your complexity lies, and it also frees up your network and allows your network to scale. Okay. So one of the important things about one of the important characteristics about microservices is the decentralized data management portion of it. So in a typical scenario, in a typical application monolith, you'd have a database. As an example, you'd have a database, and you'd have a lot of services and a lot of functionality talking to that database. And it would be, for instance, a SQL server or an Oracle server. It doesn't really matter what it is, but your monolith would consume those services. So you get pretty much bound into that structure, where, as opposed to a microservice architecture, you can have multiple different types of databases, because really what you're looking at is as a product, what does your microservice produce? So you could have I mean, there are quite a lot of different data stores these days, and they have different use cases. So relying on one type of database is not really efficient these days. So you could have some microservices consuming a SQL database. You could have some consuming an object store. You could have some consuming NoSQL. It doesn't really matter, because on the microservice level, you have your dumb pipes and your smart endpoints, and you're just consuming the smart endpoints, and so it doesn't really matter what underlies it. So you end up with a system that can scale very quickly, and it's very modular. So that's one of the real big advantages of this. And another important thing is, I mean, it doesn't really matter what languages you're using inside your microservices. So you could have a microservice. You could use domain-specific languages, for instance, to build certain things. So if you were doing mathematic modeling, or financial, or anything, graphics or video rendering or anything, you could have the same set of microservices running and producing the results in a consistent manner without affecting the way your whole system works. So you get to use the best of breed components in building microservice applications, which is really great. And it also means you can swap something out. So if you get tired of paying $1 million for SQL Server, you can drop a Postgres database in there if you want to. And it doesn't really affect your microservice layer, because you're actually just changing out the database portion of it. And it's that kind of functionality is very difficult to do inside monolithic applications. Okay, so the next thing I want to look at is the infrastructure automation, which is actually a very important part of building microservices. Microservices scale, so you can end up with thousands and thousands of microservices running in a big system, and so you need a way to actually manage these properly, because it can get out of hand pretty quickly. So a typical way to do it would be to use something called green-blue deployment. So you'd build the microservice in dev, and you'd publish it through to QA and testing. Then you'd have a router here which routes your client would actually be consuming a microservice in your organization, but you would tell the router to actually switch over to the blue implementation on the microservice. So you deploy to blue, and the router actually starts to route people through to blue. And then you can monitor blue, and if blue performs properly, you switch it on to green. If it doesn't, you just roll the transaction back to green. So that's an example of the kind of level of DevOps that you kind of need to have to run microservices properly. And this is one simple example. But if you run thousands of microservices, this kind of scalability of management gets very important. Okay, and one important characteristic of microservices is you need to design for failure. And you want microservices to fail as quickly as possible if they're going to fail. And so rule number one, your microservices are going to fail. That's a given. It's just a matter of when. And so you need to be prepared for when that happens, and you need to have a contingency plan to make it happen. Especially if your microservice is scaled out on different nodes. You have a very busy microservice, for instance, maybe running on 100 nodes, and then something goes wrong. You need to have a contingency to be able to get that system back online as fast as possible. You have to assume things are going to break. It's very important, and you need to be able to preempt failure within your system. So, for instance, one of the important things in microservices is monitoring. You need to be able to do real-time monitoring on your microservices. So as they get deployed, you need to be able to see what they're doing with the CPU. You need to see what kind of memory they're using. You need to see if they're running from start to completion, and you need to see if they're starting to throw errors. And when they do that, through your real-time monitoring, you should be able to, at that point, automatically roll back the microservices or switch back to the green in the red green deployment, for instance. So you kind of need to be prepared for all kinds of eventualities, and there are quite a lot of eventualities. I'm not going to go into all of them tonight, but that's very important in this kind of infrastructure to be able to do that. So your DevOps team is having a strong DevOps culture in an organization that is deploying microservices is very important. So one of the largest microservice implementations out there right now is Netflix. Probably most. So during peak hours of Netflix, Netflix runs entirely on microservices. They probably have a handful of microservices that they use. I'm not sure exactly how many, but it's not really a large number if you think about it technically. But they spin up a huge amount of microservices. During peak hour TV watching hours, Netflix on its own consumes 30% of all internet traffic in America, and those are all running on a microservice structure. Very, very, very scalable system. I mean, what they've done is very impressive. So, for instance, one of the things Netflix has done is they've written something called the Simian Army, and the Simian Army goes out every day during office hours and goes out and tries to break their microservices on purpose. And that's all it does. It goes out and breaks microservices and sends reports back. But that's an example of the kind of level you need to go to be able to watch your system and track it and to find things that might go wrong with it. And if you're building microservices and are interested in them, Netflix have open source Simian Army, and it's available on GitHub, and you can download it and implement it. Okay, so one of the interesting features that have emerged out of microservice design is something called evolutionary design, and that means it's very easy to evolve systems. When you're starting to work with them, when you work with a monolith, you get to a point where change starts to become very difficult. And I'm sure a lot of you worked in organizations where you get a change request or a bug gets logged or something. It's an entire process to get that code fixed, get it into QA, get it tested, get it into production. I mean, something as simple as like that could take weeks to actually happen. Unless it was obviously critical, you can get it through faster. But the actual process of getting things fixed inside a monolith can take a long time in big systems. And microservices can do that very quickly. So typically, something goes wrong in a microservice architecture. It's one microservice that's failing, and you can just switch it out and roll it back and fix it, and your entire system can carry on running. So, yeah, that's pretty critical. And one of the things that gets asked quite a lot: what are microservices, and where do they fit into the whole picture? So, if this was the service-oriented architecture environments, microservices are actually just a subset of SOA. They don't replace SOA, they're just a subset. You still have your monolithic services running inside there, and you still have your messaging apps, and you still have your enterprise service buses. Those are all service-oriented architecture frameworks, and they all run in that space, but microservices are just a subset of that. So they're not... When you start to implement microservices, you're not moving out of the space. You're just implementing a very specialized part of SOA. And okay, so if we look at monoliths versus microservices, on the monolithic side, monoliths are very familiar to all of us. Most of us have spent our entire development careers building monoliths, be it web services or applications or middleware, or it doesn't really matter. We spend most of our time building monoliths, so it's familiar. So it's quite easy to build a monolith, even if it does something simple like WordPress or delivering some kind of service on the internet. It's easy to spin it up. It's simplicity. There's simplicity in building monoliths. But that hits a barrier in terms of what you can actually do. So in the last 15 years or so, there's been a lot of stratification inside monoliths. So frameworks, libraries, stratification in architectures. There have been mechanisms to try to overcome this, and it has helped a lot to make monoliths a lot more manageable. But you still get the loosely coupled part of that, the loosely coupled systems that you get with microservices, that kind of thing within monoliths. It's actually easy to break that and to write tightly coupled code that if you're in a hurry and you need to fix something, you bypass the architecture and fix it. And over time, those kind of little things build up, and you end up with quite often with code rot and having to rewrite systems every few years. And I'm sure quite a few of you have been in those situations where you have to rewrite systems. It's coming back to, and I just touched on that earlier, intermodule refactoring, keeping your layers apart, can become, it's more of a discipline inside monoliths, but in terms of microservices, it's part of the architecture, and you can't actually break that pattern. It's baked into microservices. So you don't get that tightly coupled mess that starts to happen in code bases after a while inside monoliths. So some of the features of microservices, as I mentioned earlier, you can have partial deployment. So you can fix certain things inside certain services and deploy them. You don't have to roll out the whole application. If you've got a calculation that you work out, that works something out faster, and you find a way to do it, you can just change the calculation inside the one microservices and deploy it. And so you can do lots of micro deployments in the microservice environment. You also have a lot greater availability. The infrastructures that support microservices scale a lot better. So if a microservice gets busy, the modern microservice architectures scale up very quickly to meet your needs. So if you're looking to build something that's going to scale a lot bigger, I would definitely recommend going with a microservice architecture than a monolith. And an important part, as I mentioned earlier, it preserves modularity. You get which you start to work within your domains, and you start to build microservices that do specific things within those domains. You get really good modularity, and that's very useful down the line. Most code that gets worked on very few of us ever get to write a green room application from scratch and build it up. It's actually it's a rare occurrence these days. Most of us spend most of our days doing code maintenance, and so you're going back and reading code that was developed 5 years ago, and you have to go through the logic, and you have to kind of understand it, and it can get boring and tedious after a while. And when you start to build with a microservice architecture, you get very, very loose, very single. You get microservices that do very simple things, and they're very easy to understand. So there's a lot of simplicity inherent within building microservices if you do it properly. The consistent interface, you have your dumb pipes and smart endpoints. They typically talk a standard. So at Dev2, when we build Werewolf, so we talk JSON and we talk XML. Those are our standards, and it talks across HTTP. There are other types of microservices that run other platforms, other protocols, but we use standards, and those standards are universal. And it doesn't matter what our microservices do when they communicate with each other. They're talking HTTP and they're talking XML and JSON. It's a dumb pipe and smart endpoints, and which gives the ability to build very big and scalable systems, and allows you to adapt and change and be agile with your systems over time. So you don't get the mutable boundaries, as I mentioned earlier, that you get with monoliths, and you can work on multiple platforms. So you could have as many types of databases as you need, or you could have inside your enterprise bus. It doesn't really matter what you run. You can build a system out of anything that you need to do to build something. You're not kind of limited to one kind of technology like C++, C# or F# or whatever, or any kind of domain-specific language. You can actually use anything. It doesn't really matter as long as you keep you keep to the principles of smart endpoints and dumb pipes. And one general point about microservices is that they're not straightforward. We've overcome that problem, but generally microservice development is not straightforward because you have all the deploying them and building them can be quite arduous, but definitely worth in the long run if you're looking to build very big systems. So just some requirements. If you're going to be building microservices, okay, I'm done. This is the last bit. Essentially, you have to have rapid provisioning. You have to be able to roll out microservices as quickly as you need to, and then you need to scale as quickly as you can. You need to have basic monitoring in place. If you're not doing that, you're wasting your time. You need to have a mechanism to deploy microservices rapidly, and most importantly, you have to have a strong DevOps culture. You can't have your development team and your ops team sitting in different places and sending each other emails. You need to be able to shout at the guy next to you, hey, this is not working, fix it up, please. And that's the kind of level. You need to really have DevOps culture to make it work properly. And what is important but not essential, if you're building business systems, you need to be able to trace what's happening through your microservices, especially when you have embedded microservices or microservices calling other microservices. A continuous delivery mechanism to roll from development into production, very important. Not essential, but important. And also to have your teams changing their way of thinking to work around delivering product, delivering microservices that actually do something and deliver something. It's very important. And when you started to get into big organizations, you can have a microservice team building microservices, but those microservices might be consumed by other things. So for instance, you could have a microservice team building microservices, but you might have a mobile team developing with iOS or Android, and they'll be consuming the same microservices. But microservices work very well in a multi-development environments, and microservices are very complementary to all kinds of other technologies because it's a standard way to do things. So from that perspective, I would really recommend them. And that's all, folks. Thanks for listening. Do you have any?